Okay, welcome once again to my YouTube channel. It is still your tutor Peter Ikaja, and today I bring you a new tutorial, particularly on the change of the variable t equals to tan x out of 2. Now, in this tutorial, I'm going to be helping you to understand when we use a suitable substitution of t equals to tan x out of 2 to integrate. It's really going to be a supportive measure. It's going to be a supportive technique to help us specifically tackle some of the stubborn integrals. I have the very first one on my screen. One is we find the integral of 1 over sine x dx. This can also be called integral of cosec x with respect to x. Take care about that. Now, I'm going to show you two ways of doing this very question. But at the end of the day, in all of them, we shall still use the change of variable t equals to tan x out of 2. The very first one is going to be, we can say integral of 1 out of sine x dx can be as good as integral of 1 divided by 2 sine x out of 2 cos x out of 2 dx. What I've done is I've expressed sine x in terms of half angles, and these ideas all come from one of the topics in trigonometry that talks about double angles and half angles. Now, after doing this, I can clearly say that now the next step becomes integral of, I am going to divide both up and down by cos squared x out of 2. That's what I'm going to divide by, but it's going to be up and down. So I'm going to get 1 divided by cos squared x out of 2. I come to the denominator also. We have 2 sine x out of 2, cos x out of 2, but I also divide this by cos squared x out of 2. The whole thing, we're integrating it with respect to x. Should you look at this carefully, this translates to 1 over cos squared, which is sec squared x out of 2, and then divided by, when you come down here, sine x, okay, cos x can reduce the one we have down here by 1. So it means I will have sine x over cos x out of 2, sine x out of 2 out of cos x out of 2, which will give us tan. We have a 2 here, so it means I will have 2 tan x out of 2 dx. From here, we can clearly see that sec squared x out of 2 is the same as 1 plus tan squared x out of 2. That means we shall now have integral of 1 plus tan squared x out of 2 divided by 2 tan x out of 2 with respect to x. From there, we can clearly see that now there is need to let t to be tan x out of 2. So now I will say for this integral that we have, for now our integral 1 plus tan squared x out of 2 that we have divided by 2 tan x out of 2 dx, we can comfortably let. We shall let t to be tan x out of 2. When you let t to be tan x out of 2, then you get the t dx. So the t dx now becomes a half. You first differentiate the angle, remember? When you differentiate tan, you get sec squared, but of course of the same angle. And that means at the end of the day, when you make dx the subject, dx becomes 2 dt divided by sec squared x out of 2. But this translates to 2 dt divided by 1 plus tan squared x out of 2. I'm showing all the details being the first example, and then which means you actually have it as 2 dt divided by 1 plus t squared. Why do I say 1 plus t squared? It's because where there is tan x out of 2, we are representing it with t. That's why we have that. So if dx is that, we now come and say integral of 1 plus tan squared x out of 2 divided by 2 tan x out of 2 dx is now going to be equal to integral 1 plus actually t squared. I am substituting for tan as t, so it means I will have that out of 2t. But then remember, the x, we already made it the subject here. It became 2 dt divided by 1 plus t squared. When you look at this carefully, 1 plus t squared can cancel with 1 plus t squared. These ones can cancel out, the 2 can cancel. So we just remain with integral of 1 out of t. And when you integrate 1 over t, you definitely get natural logarithm of t plus a constant. But then remember, we had already said t is tan x out of 2. So the answer becomes natural log of tan x out of 2 plus our arbitrary constant of integration. So we can conclude, therefore, that actually our integral of 1 over sine x with respect to x is just as simple as this. Let's look at the alternative for this very question. Alternative. Now, we can say clearly that integral of 1 out of sine x dx being our question, we shall begin right away by saying let t equal to tan x out of 2. Now, this t being tan x out of 2 gives an implication that actually sine of x from what we call the t-formulae in trigonometry is going to be 2t out of 1 plus t squared. Please, this was derived in trigonometry, so we have quoted a standard result. And that means now I can proceed with this and I differentiate, get the t dx, which is definitely a half as x squared x out of 2. And I said already, I showed you how to simplify this in the previous alternative. If you make dx the subject, it becomes 2 dt divided by 1 plus t squared. Now, from here, I go back and substitute. I now say integral of 1 over sine x with respect to x is equals to integral of 1. In the place of sine, we shall put its t formula. That is 2t out of 1 plus t squared. And then we multiply by dx, but dx is 2 dt divided by 1 plus t squared. When you look at this carefully, it can go to integral. I'm now going to take the reciprocal here. So it will be 1 plus t squared divided by 2t multiplied by 2 dt divided by 1 plus t squared. So you realize again, 1 plus t squared and 1 plus t squared can cancel out. 2 will reduce, so that we end up with 1 over t. So it means now we have integral of 1 over t with respect to t, which is definitely a natural log of t plus an arbitrary constant. But remember, t from the start was tan x out of 2. So the answer still comes to tan x out of 2 as it was before. So we can have that conclusion as it was in the first option that we took up. So now we can also now find out what happens with our integral of 1 over cos x with respect to x, or it can be called sec x with respect to x. We shall just look at the fact that the integral of 1 out of cos x dx, I'm going to use alternative number 1, is just as good as integral of 1 out of, and when you come to cos x in terms of half angles, it can be cos squared of x out of 2 minus sine squared of x out of 2 with respect to x. That is again from trigonometry. Then from there we come and say we are going to divide through by cos squared up and down. That means we shall have 1 out of cos squared x out of 2, divide everything by cos squared out of 2 divided by cos squared x out of 2 minus sine squared x out of 2 divided by cos squared x out of 2 dx at the end of the day. So from there, we can easily see that now we shall have integral of 1 over cos squared x out of 2, which is x squared x out of 2, divided by cos squared over cos squared is 1, so minus sine squared over cos squared is tan squared x out of 2 dx. From this point, we can now realize that actually x squared is 1 plus tan squared, so we shall have 1 plus tan squared here, x out of 2, and then divided by 1 minus tan squared x out of 2 with respect to x. So now here we are supposed to let our t to be tan x out of 2 and proceed as follows. So we let t to be tan x out of 2, dt dx will definitely be a half x squared x out of 2. That means dx becomes 2 dt divided by x squared x out of 2, which is 1 plus tan squared, but tan is t, so it will be 1 plus t squared, as I explained in the previous question. Then from here, we can now say integral of 1 plus tan squared x out of 2 divided by 1 minus tan squared x out of 2 with respect to x is now going to become integral of 1 plus t squared divided by 1 minus t squared. In the place of dx, we have 2 dt divided by 1 plus t squared. The 1 plus t squared again will cancel. As you can see, the 2 remains up, so we shall have a 2 divided by 1 minus t squared dt. But then when you look at 2 out of 1 minus t squared, it can be written as integral of 2 now out of 1 minus t squared is the difference of 2 squares. So I can say 1 plus t into brackets 1 minus t dt. That means we're now going to go for partial fractions, particularly type 1. So we shall let 2 out of 1 plus t into brackets 1 minus t be equal to a out of 1 plus t plus b out of 1 minus t. That means 2 now is equals to a into brackets 1 minus t plus b into brackets 1 plus t. And then from there, we use the cover-up method. If we put t equals to 1, that is, if we put t equals to 1, we shall have 2 on the left, on the right-hand side, we'll have 2b, and that means b becomes 1. If we again put t equals to negative 1, we shall have a 2 on the left, and then on the right-hand side, we shall have 2a. That means the value of a also becomes 1. So we can now make a conclusion that actually 2 divided by 1 plus t into brackets 1 minus t is actually equal to a, but a is 1. 1 out of 1 plus t plus b, but b is also 1 divided by 1 minus t. Now, integral of 2 divided by 1 plus t into brackets 1 minus t dt is just as good as the integral of 1 plus t dt plus the integral of 1 out of 1 minus t dt. When you integrate these functions carefully, you will end up with the first one will give us a natural log of 1 plus t. And then the next one, be careful, we have a negative coefficient of t, so it will be minus the natural log of 1 minus t plus a constant of integration. So we can now go back and make our real conclusion from where we started from, that in conclusion, integral of 1 over cos of x with respect to x is actually equals to ln of 1 plus, remember our t was tan x out of 2, minus natural log of 1 minus tan x out of 2, and then plus a constant, and that becomes our result for this particular integral. It was a good one, but then not really technical as someone might think out there. I still remind you to subscribe to this channel, turn on the notification button so that you don't miss the next uploads with myself. See you in the next tutorial for the continuation of this work. Bye bye.